Okay, here we go, 14. Okay, again, make sure you're reading slow. It says the graph of a twice differentiable function f is shown in the figure above. So let's explain what twice differentiable means. If you have a function f, and you are able, at every xy pair, to calculate the rate of change or slope of f, or derivative of f, those are all the same thing. That means f is once differentiable. So if I can find the slope of f at every point, that means f is once differentiable. Questions on that?
Can you say that one more time?
One more time. So you have some graph of f, like we don't know what the graph is. So just pretend I draw some graph over here of f. Well, just say it as a class. Does this graph of f have any discontinuities, yes or no? No. So far f is continuous. Does f have any corners, yes or no? Say it. No. Does f have any vertical tangents? No. That means f is differentiable at every point. So I could go to every point and I could find the slope of f. If I find those slopes and I write them down, that's going to make a list. That list will be right here. So that list will show me every slope of f. That means f was once differentiable. It is literally like learning a new language. I get that. That means f is once differentiable.
Wait, can you say that one more time?
Many times as you want. So we've got f. Ellie, can we find the slope of f at every point? That means f is once differentiable. To differentiate means to find the derivative, and derivative means slope. So, which girl would you like to interview? I think we'll be quick. If it's not quick, we'll come out and do something about it. Famous Paisley. Did I answer your question, Ellie? Okay. Anybody else? Solid. Look, if you take these numbers and you plot them as a graph, and then you go calculate the slope at every point on f prime, that would mean f prime is once differentiable.
But then would that mean that the normal f is twice differentiable?
2 points for Josie.
Gotcha.
That means that f itself was twice differentiable.
So that graph's just a graph of f double prime?
So this is a graph of f, and they're telling you that this graph can be differentiated twice.
Okay.
So they're saying, hey, we're looking at f, and what's one characteristic of f? F is twice differentiable. 2 more. Please.
Can that go on forever? Like, can you go, f is differentiable, f prime is differentiable, f double prime is differentiable? Can that just go on forever and ever?
For some functions, yes, but not all functions, yes. 2 more, please.
So how are you supposed to find out that f double prime is different, or f prime is differentiable?
Oh, in this case, they're simply telling you that it
Will
is.
they ever tell us, or will ever have us find it?
Oh, gotcha. Once in a while, like number 9, they asked you, they were testing you, Kai, on number 9, to see if you could identify where this function f was not differentiable. And you were able to do that. They will test you on that. They won't typically ask, I've never seen them ask you to prove that a given function is differentiable everywhere. Like, I've never seen that. 2 more, Lizzie.
So when it's talking about stuff that's differentiable, is that like saying that it's continuous and it doesn't have any corners?
Hey, look over here. Look up, look. This is really good. 2 more for Lizzie. Really good. If you know that f is once differentiable, then you know for certain f is continuous. Otherwise, f would not have been differentiable. You also know that f has no corners and f has no vertical tangents. If you know that f is twice differentiable, you know all of that is true about f prime as well. Please.
So if it says it's once differentiable, does that mean that you know that f prime would have like a corner or like something that makes it not differentiable?
2 more for Lizzie. Perfect. So if, I'm just saying it back to you. So if f is once differentiable, but not twice, that means you were able to find the slope of f everywhere, but when you plotted f prime, suddenly a corner appeared, a discontinuity appeared, something that causes so you can't find the slope of f prime. 2 more.
How do you create f prime again, like using f?
We have not learned precisely how to do that. We will in Unit 2. So far we've just done it in kind of a general sense. Like, I could do it with this one. I could say this is f. They told us this is f. So you could go right here, Christiana, and we would measure the slope of f right there. That slope there is that slope positive, negative, or 0. Positive. We measure another slope. Positive, negative, or 0. More positive or less positive than the blue? Less positive. You're going to plot the slopes. What you plot becomes f prime. So I take the fact that that blue slope is positive, and I plot that as a y coordinate. I can't really measure how positive it is, so I just say it's positive. I plot that as a y coordinate in line with that location because that's where the slope was positive. Then you go to the yellow and you do the same thing. That slope is less positive, so you plot that as a y coordinate. The slopes become steadily less positive, so the graph of f prime is going to look something like this. That's where f prime comes from. F prime is simply the slopes of f. Christian, I can't tell if I helped or not.
No, yeah, that helps.
Okay. If you look at your reference sheet, there's a huge part of the reference sheet that is meant to help you with that exact question. So look at your reference sheet. It shows f and f prime. And you can see that it's doing exactly what I just did. Right here, just say it together as a class. Right here, slope of f. Okay, first of all, y coordinate right there. Is the y coordinate of f at this spot positive, negative, or 0? Say it. Positive. Is the slope at that spot positive, negative, or 0? Say it. Negative. That means the y coordinate on f prime must be negative. So right here I have a negative y coordinate. That's f prime. If I go along a little further, the slope of f becomes slightly less negative. That means the y coordinate on f prime becomes less negative. That's what f prime is. Please.
On the test, will we get to use the reference sheet or no?
Gotcha. So on the AP test, 2 for Lizzie, you are allowed no helps at all. So I've got to get you to memorize this stuff as soon as I can. If I wait clear till April, it's a disaster. So no help on the test. So I give you the reference sheet to help you prepare for the test, but you cannot use this on the test. Good question. Please.
Maybe like this next test, we can't use it?
Correct. So the reference sheet is simply to help you prepare for the test on September 16th, but you cannot use it. John?
Is f double prime the same as f of x? Then, like, when you do it, will it end up being the exact same line?
It's not a circle. F prime is the slopes of f. F double prime are the slopes of f prime. You can go right here, John. John, right here, what's the slope of that f prime graph?
Positive.
Positive. Therefore, the y coordinate on f double prime is positive.
Okay.
If you keep going, go right here, John. The slope of f prime right here, right there, John, is the slope. What's the slope of f prime right there?
positive?
More or less positive than the green?
More. More or less?
I said that badly. So we have the green slope, right?
Yeah.
The green slope was positive. We move to the purple slope.
Oh, it's less.
Less positive. There you go. Does that make sense?
Yeah.
That means the y coordinate on the f double prime graph must be less positive. And it is. Here's the corresponding dot on the f double prime graph. Less positive. 2 for John. Anybody else? Oh, please. Yeah, you're good. You know how to use the little thing here?
Yeah, I did.
Yeah, go ahead. Yeah, please, Annalise.
Like, how do you know, like, how high to start? Like,
Gotcha. Look up, look up, look up, look up. 2 more for Annalise. For Unit 1, we're not doing any what's called quantitative analysis. Quantitative means we're assigning precise numbers to what we do. We're doing what's known as qualitative analysis. Qualitative means the same concept, but we don't really stress about the details of the numbers. So I know that this green slope is positive right here, Annalise. I don't really know how positive, and I don't really care. So I just know it's a positive value. I know the purple slope is less positive, so I know the next green dot's got to be lower, but beyond that, we don't care for now. Does that answer your question? Okay. 2 more. Anybody else? Okay, back to the one we were working on, which was number 14, yeah? Okay, so we know we're looking at f, and f has 2 derivatives. Big hint for the AP test, this clue right here, the fact that f is twice differentiable, I have found in my many years of experience that I will use that clue only about 20% of the time. The other 80% of the time, I don't need that clue at all. They'll give it to me, but I just don't use it. This is an example of that. I don't really use the clue. Okay, they gave it to me so that I would know that, hey, finding f double prime of 1 is possible. Finding f prime of 1 is also possible. That's why they gave the clue. But I don't really need it. Okay. Questions? Awesome. This problem is a great example of where Danica's chart is so helpful. We're supposed to figure out which one is true. It's like a true-false question. Well, they're only talking about one point on the graph, x equal 1. So you're only looking here. So hands up, everybody. What can you tell me about f at that point? Like there's several things you can observe about f at that point. F is this graph. That means f is these these xy pairs. What can be said about f at or near x equal 1? Hands up. There we go. What can be said about f at or near x equal 1? Let's go, Brady.
Positive slope.
So you could say that the slope of f at x equal 1 is positive for sure. How you say that, be a little careful, it can lead to mistakes. So I can do this. I could say I've got x. Okay, 2 points if your hand was raised. I've got x equal 1. And I've got f. Well, rather than say that the slope of f at x equal 1 is positive, I'm going to do that mathematically. F prime represents the slope of f. So I know that the value of f prime when x equals 1 is going to be a positive number. Just like I said to Annalise a minute ago, I don't have a way to calculate that number yet, but I don't need that for now. Positive is good enough. Questions? Jason, please.
I'm confused how you know it's going to be positive.
So, this is f. Good with that? As you check the xy pairs of f, are those xy pairs, x is going up because that's how we read. Are the y values going up or are they going down?
They're going up.
They're going up. That means they are changing at some rate that causes them to go up. That means the rate of change must be positive. Slope means the same thing as rate of change. So that means the f prime value at that moment must be positive. Does that help?
Yeah.
2 more. Anybody else? Cool. There's something else we can say about f at that point. Hands up. What else can be said? Now, hands down for a second. Look at me. Look. Okay, I'm trying to get all of you to convert from previous classes where you were essentially shown how to do something and then you had to repeat it. I'm kind of biased about this, but the value of show and repeat is getting less and less in this world. Like it just is losing value rapidly. It used to be a great value that people could memorize whole books because there was no printing. So if you could memorize a whole bunch of information, you were considered very valuable because there was no way to print anything. Once we could print things, that skill disappeared. Like no one on the planet today is considered of great value if they can simply remember everything, because the computer can remember it far faster, far better. So you're learning how to like truly think. That is the value of this class. We attack a problem like this. Notice, I can never do this in this class. I never say, here's step 1, here's step 2, here's step 3. I'm just trying to get you to learn how to talk about it. They show you f. They ask questions about f, f prime, and f double prime. So we just started talking about it. We said, hey, what do we know about f at x equal 1? So hands up again. What else do we know about f at x equal 1? What else do we know about f at x equal 1? Audrey?
It's continuous.
So f is definitely continuous. 2 points for that, 2 points if your hand was raised. I pause at that moment. I ask myself, true, but that doesn't really help me figure out like f of 1, f prime of 1, f double prime of 1. So true, but just not really helping. Other hands. What else do we know about f at x equal 1? But in some cases, Audrey, that will be essential. So make sure you keep that. Let's go, Ellie. That's helpful. At this moment, 2 points if you knew that. Look, at that moment, f is concave down. Danica's chart is super helpful now. Danica's chart says, hey look, if f is concave down, that means that the slopes of f are going to be decreasing. That means if you look at these numbers here, those numbers will be positive, but they'll be going down. They're becoming less and less positive. The slopes of f will be becoming less and less positive. You can see it here. This slope of f is positive, but this slope of f is less positive, just like John did a minute ago. So f is definitely concave down, and if the slopes of f are decreasing, f double prime is the slope of f prime. So if f prime is going down, that means the slope of f prime must be negative. So we know that now. We can put that in our chart. So we've got f double prime here.
How did we get the positive for f prime?
So f prime is the slope of f,
Yes.
or rate of change of f. As you examine these xy pairs,
Oh, okay.
we see them going up.
Yes.
You're doing great. So f is increasing, therefore the values of f prime must all be positive. Okay, I have now done enough to answer the question. Who knows the answer? Hands up. Oh, we got to do one more thing. Hands down. We never said something crucial about f. What is crucial about f? No one's pointed it out. It's like the thing you knew before you even came to this class. What's true about f at x equal 1? Let's go, Simon.
Y is 0.
Yeah, the y value is 0. 2 points if you knew that. Now we can answer the question. Hands up. Who knows the answer to the question? It's a great example of you don't solve the problem by doing step 1, step 2, step 3, because that's impossible in this class. There are no steps. There's no steps. It's just you've got to understand the idea and then apply it, which is very similar to many, many professions. So here we go. So what is the correct answer of Lincoln Massey?
D.
So Lincoln goes down to D. And he says, hey, look, f double prime of 1, which we found to be negative, is certainly less than f of 1, which we found to be 0, and f prime of 1, which we found to be positive. Okay, hands up. Who knew? Two more. Okay. Who wants to talk about it more? We can talk as much as you want. Yeah, please, Kate.
I don't get why F double prime is negative.
Is negative.
Yeah.
So, are you comfortable, Kate, that right here, the slope of F is positive?
Yeah, is it because it's causing down?
No. Let's back up a
Or
step.
is it because it's increasing?
Increasing.
Oh.
Because F is increasing, so it's right here. Because F is increasing, okay, remember, slope means rate of change. If the values are going up, they're changing in a positive way. They're getting more, they're going up. With me?
Yeah.
That's why we know that F prime is a positive value. Okay, whole class. If we look at the slope right here, raise your hand, please. Is the slope right there on F positive or negative? Hands up. Is the slope of F right there positive or negative? Slope right there, Camden, positive or negative? 2 points if you knew. So if I'm making a plot, I'd say, okay, I got X, I've got F, and I've got F prime. Like at X equal negative, I don't know, 0.8 or something. F prime is some positive number. Okay, we don't know the number, so I'm just going to say 10. We don't know, we just say 10 so we can talk about it. We move along the graph. Right here, hands up. What's the slope of F right there? That's what finding F prime means. Find the slope of F. What's the slope of F at the blue? Somebody knew? Let's go, Anna. Anna says positive. You knew that. 2 more points. Anna, more or less positive than the green?
Less.
So I'm going to say positive 8. Okay, look. F prime is decreasing. F prime is just a bunch of dots as well. They have a rate of change. If these values are going down, then the rate at which F prime changes is negative. That's how we know F double prime is negative.
So
But the-
F double prime is the slope of F prime.
Perfect. 3 more for Kate on that one. F double prime is nothing more than the slope of F prime. It's perfect. Now the quick way to do it, Kate, is just Danica's chart.
Yeah.
You say, hey, F in that region is concave down. And concave down means the slopes of F are decreasing. Therefore, the slopes of F prime, I said that badly, since F prime's values are going down, that means the values of F prime, which are the slopes of F, must all be negatives.
Yeah.
Anybody else? Next one, cool.